Hello, eighth graders. I hope you guys are all doing well, staying safe, wearing face masks. I'm going a little stir crazy because I can't see you guys and it's kind of driving me crazy. I love teaching, so this is going to have to do for me. This is a lesson about mapping diagrams, and the B classes are lucky because I'm going to actually go over it in person with you guys. But the A guys, you have to wait till Tuesday, and I have to submit this by Monday. So here we go. So our lesson's about mapping diagrams. I know you guys think of a map as like something that you use for directions, but in this case, a map is for telling about input and output of a certain function. So it's basically a relation. So a mapping diagram shows a relation between input and output values. So in a mapping diagram, as you can see, there's like an oval on the left and an oval on the right. It kind of looks like a Venn diagram, except not in the middle. There's no circle in the middle. So it's a diagram. And on the left-hand side, is the domain. The left-hand side is also called the x value, or the input. So thinking of if you're reading from left to right, your input's always going to be on the left. And the range is on the right. And that's also known as the y value, or the output. So can you think of a way that you can remember these two things? It took me a really long time. And in fact, I didn't learn this until I started teaching it, what the difference between domain and range was. So I know they're kind of like really weird terms. So here's my example of how I learned how to differentiate the two. In order to feed our chickens, we need to go inside, which is input, the house, which is the domain. So input is the domain. Before, and it's x before y, before we can get some chicken feed to take outside, which is outside, to the range to feed the chickens. So we've got x before y, input and domain are first, output and range are second. So when you've got a mapping diagram, you can also form ordered pairs. The way you do that is you take the x and you match it up with its corresponding y, like where the arrow is pointing. So for example, -1 would go with 5, 0 would go with 3, 1 would go with 5, 2 would go with 11, 3 would go with 21. So if you do that in the order that I just said, -1, 5, so -1, 5. 0, 3 would be 0 goes with 3. 1, 5, 1 goes with 5. 2, 11, 2 goes with 11. And 3, 21. The next thing you can do with those values is put them in an XY table. We've seen these before, right? XY, when you in our last week's assignment, we had XY tables. So the X would be the domain. So the first X would be, I'm going to use these values, -1, -1, and its corresponding Y would be, what? 5, you guessed it. The next one would be, you say it out loud, 0, and then its corresponding Y value would be 3. The next one would be 1, and a corresponding 5. And then we've got 2 and 11. And finally, we've got 3 with 21. In this table, you notice that each X has a different Y with it. I see there's a 1, a -1, and a 5 here. That's not really the same as 1 and 5. It's different than -1 and 5. So each X has a different Y input. Now, some mapping diagrams are functions and some aren't. If they're not functions, they're just called relations because they relate an X with a Y. So you're probably wondering, how do you know when they're a function? Well, That's where I come along. I'm your teacher, so I will tell you. So this example is of when yes, it is a function. The following mapping diagram is an example of function because for each input, 10, 20, 30, 40, there's only one output. So yes, it's a function. So what I mean by that is each input has a different output. So 10 has 15, 20 has 45, 30 has 25, 40 has 35. And if we put them as ordered pairs, we would go 10, 15, 20, 45, 30, 25, 40, 35. And what about if we wanted to put it in a table? So that would be a 10 here and a 15 here, 20 here, 45 here, 30 here, 25 here, 40, and 35. And the way I got those were I just followed the little arrow from each X or input or domain number to its corresponding output. What if we wanted to list all the different X values? What are they? So they're all here and all the Y values are here. So we go 10, 20, 30, 40. Those are the X values. And the Y values would be 15, 45, 25, 35. So that, my friends, is an example of a function. It's yes. It's a yes because each output is different for each input. Let's go and see what an example of a non-function would be. So I made this in red because red means like stop and it means kind of like no. So the following is not a function because each input does not only have one output. One of them has two different outputs. So 2 could go to 20 or it could go to 40. Uh-oh. One input cannot go to two separate outputs. So therefore, it can't be a function. Yes, 4 goes to 40 and 3 goes to 30, and they're kind of out of order. Normally, we list them in order. But so if you listed them as ordered pairs, it would be 220, 240, 440, and 330. But notice the 2 appears twice. So that is kind of like a no-no. So again, if we're going to put them in our XY table, we would go 2, 20, 2, 40, 4, 40, and 3, 30. Notice that 4 and 3, I mean 2 and 4 both have 40, which is fine. Two different X inputs can have the same output, but two different inputs cannot have the same have diff, the same input cannot have two different outputs. I know it's kind of weird. So one example of that would be like say your name is Sally. So number 2, let's say number 2 is Sally. Sally's 2. And her grade in math is a 90 degrees. I mean 90%. But her grade is also 80%. Well, that doesn't make sense because she can only have one grade. So Sally can only have one grade, so therefore it's not real. It doesn't form a function. Can't be real. So you could take your own name and you can only have one grade. A lot of you have A's and B's right now, which I am super happy about. And then you know that one X can only have one Y. It can't have more than one Y. But on the other hand, two people, two X's, 2 and 4 are allowed to have, or 2 and 4, yeah, are allowed to have the same grade. Like Bobby and Susie can both have a 90 degree. I mean a 90%. Okay, so let's list what the X values are. 2, 4, 3. And the Y values are 20, 40, 30. So here's our summary. What's a mapping diagram? It's a diagram that shows a relationship between an input X, could also put domain, and an output Y range. What information is found in a mapping diagram? So we could say inputs are X and outputs Y. Input is the domain, output is the range. How can we tell if a mapping diagram is a function or just a relation? A mapping diagram is a function if each input has exactly one output. Otherwise, it is a relation. Otherwise. So it is a function. I make that yellow. If each input has exactly one output. You could say only instead of exactly one output. So I hope this helped you to understand mapping diagrams. We're going to have an add puzzle on this and then a little bit of practice. And then I think you guys might be ready for a quiz. During our Zoom sessions, we're going to do a little practice with this. Okay, guys, see you later. Have a great day.